everyone, I am Vishwara. Today we are discussing about class 12, 11 physics chapter number 3 motion in a straight line. Okay, in this topic we are discussing about that the instantaneous velocity and the speed. Okay, now in the previous lecture we will show that the velocity and also we will show that the speed. But in this topic we are discussing about that the instantaneous. There are the new words are there, instantaneous. So first of all, what is the instantaneous? Instantaneous, it means we are discussing about the at the time, okay, at the time on when on that time on a particular, suppose you are at a 3 seconds where one when you are at that, suppose you are discussing about that the you are come from the Anand to Borsad, on that time you will be where on 10:15, okay, suppose you are the on whenever on 10:15 where you are situated. So this is the instantaneous. It means there is a particular point, okay, there we are discussing about the any small quantity, discrete quantity, or topic about the discrete quantity. It means that the instantaneous velocity, instantaneous. Okay, now now in this phenomena, in the velocity phenomena, we have shown that the discrete velocity. Now discrete quantity is that there are the dx, it means the small distance, okay, there are the small distance dx, and there are the small time dx upon dt. It will give us that the instantaneous velocity. Okay, the change in position, suppose the change in position, we were discussing at that the change in position, the very small position will be changed, okay, and on that time there are the position from x1 to x2, there are the very low position, very low time taking that to change the position from one point to another point. On that time we will discussing about that the instantaneous velocity, so and also the instantaneous speeds. So in this topic we will discussing about instantaneous velocity and also instantaneous speeds. Okay, see here. Now see here, instantaneous velocity and the speed. The hour's velocity tell us how fast an object have been moving over a given time interval, but does not tell how fast it moves at a different instant of time during that interval. For this we define the instantaneous velocity. It means how you pass from this point. Suppose you are passing from the Napa, how you will pass from this point. It means there are the small point. It is a one point, particular Napa is a one particular point, and the time will be taking from this passing from this point, there are the time taking, so this time will be very small, also it will be used as to tends to 0 time. So this is the therefore we are discussing about that the instant of time during that interval. Okay, for this we define the instantaneous velocity, or simply velocity at v at the instant time t. So the velocity at the instant is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. Okay, it means that delta t tends to 0. It is not a 0. Okay, there is a 0 time, it will not be possible. So it will be tends to 0. There is the 0.00000 something are there. So it is a infinitesimally small. This is not a 0 actually, but it is a infinitesimally small. On other words, see, v is equals to limit delta t tends to 0. Okay, limit delta t tends to 0. So delta x upon delta t. So see here, delta x upon delta t, it will give us dx upon dt. So delta, see here, delta is a more quantity, then and d is the small discrete quantity. There we are considering as the just as a look like a marble. So it is a, we have bunch of marbles are there, and just we have considered there are 100 marbles in the box. We have just consider as a one marble, and we are taking the one marble's volume of there, or then we are multiplying by 100. On that time we will get that the total volume of the marble box. So similarly here we are taking the discrete quantity. Okay, discrete quantity, it means that there are the small value of the x displacement value. So dx upon dt, we are taking that the dx upon dt, it is a integration, it is a derivation portion. Sorry, I left one topic is there, how to do the derivation and integration of this topic. We will so there are the dx upon dt. So it is a integral derivation quantities. So we will discussing in the next lecture, in next lecture 100%. So dx upon dt, dx upon dt, where the symbol of limit delta t tends to 0 stands for the operation of taking delta t as delta t tends to 0 of the quantity on this right In the writing, in the language of calculus, the quantity of the right hand side of equation is the differential coefficient. Okay, I was told you about that, the differential integration and differentiation. Differential coefficient of x with respect to time. See here, x derivation of x with respect to time t, it is denoted by the dx upon dt. Okay, what is it is denoted by the dx upon dt? It is the rate of change of position with respect to time. Okay, so see here it is a rate of change of with respect to time. This is the with respect to time. Suppose here we are taking that the v, suppose here we are taking a, it is acceleration. So on the time also we will discussing about that the discrete with respect to time, with respect to velocity, with respect to acceleration. So this is the basic funda of that. So see here it is denoted by dx upon dt. So it is the rate of change of position. There the x is the position, so rate of change of position with respect to time at the instant. Okay, on the particular time what will be change in the position are there, we are shown by this phenomena, differentiation of the quantity, differentiation of the coefficient of x. We will get that the final value of the how the change of position with respect to time we can derive. So see here we can use of equation of this, our equation number, this v limit delta t, this equation limit v is equals to limit delta t tends to 0 delta x by delta t. From this equation we can show that here see it is the, we can use that equation 3 obtaining the value of velocity at an instant, either graphically or numerically. Suppose that we want to obtain the graphically value of the velocity at time t is equals to 4 seconds at point P for the motion of the car represented in figure 3.3. See here we have shown in the previous slides the figure 3.3, but see here we have so the figure has been revolved in the see choosing the different scale of to facilitate. See here there are the position change with the see here it is a change with the time. See our, this is our time interval, and this is our the x, it is the position. So how will it change? See here it is just, it will start from this here on the time. It is see here there are the p1, it is a p2, there are the q1 q1 q, we need to determine at p point. Okay, what we will determine at p point the how much velocity are there. So but we have just a p1 p2 q1 q2 t1 t2, so there are the difference phenomena are there, but we are discussing about at particular point p, a particular point p the how much velocity are there. See t is equals to here, see here at a 4 seconds, so particular 4 second and the particular, so see here sorry, see here at a 4 second the our position, our car position are where we will discussing in this phenomena. So but whenever we are discussing about it, we suppose our graph has a curve. See it is a not a straight line. Okay, it is a not a straight line. So if there are a straight line we can calculate by the slope, but it is a motion with respect, it is a continuous speed will be changed with respect to time. It will be more increase and more increase, so it will be not, it is a continuous velocity. So there are the, we cannot use easily to by the slope, so we need to we need to take a tangent of the curve. So due to the tangent of the curve we need a particular, we are taking the small value of the curve, we are taking that the small value of the curve on that time we will get that the tangent. Okay, on that time we will derive the slope of this equation. So choosing the different scale to facilitate the, let us take a delta t is equals to 2 second, center at the t is equals to 4 second. Then by the differentiation of the average velocity, the slope of line p1 to p1 p2 gives the velocity of average velocity over the interval is 3 to 5 seconds. Now the decrease the volume from delta t from the 2 seconds to 1 second. See here, see here we are, whenever we are discussing about that the p1 to see p1 to p2 on that time it will be 2 seconds, difference is delta t is difference is 5 minus 3, it will be 2 seconds. Okay, so we will discuss decrease, we will we will decrease. See here, the average velocity, the slope of line p1 to p2 gives the value of average velocity over the interval of 3 second to 5 second. Between the 3 second and 5 second, how much average velocity are there? Now we decrease the value from of delta t from 2 seconds to 1 second. See here, 2 seconds to 1 second. It means here q1 to Q1 to Q2. So 3.5 to 4.5. We are discussing about that the value of 3.5 to 4.5. So it is a 1 second difference is there. So see here, to then the line p1 p2 becomes a q1 q2, and this slope gives the value of average velocity over the delta interval t 3.5 seconds to 4.5 seconds. In the limit of delta t tends to 0, the line p1 p2 becomes the tangent of position of time curve at the point p, and the velocity delta t is equals to 4 seconds. So see here, what we will do, see here we are discussing about the p1 p2 q1 q2, but now we are drawing the tangent. Okay, there are the drawing the tangent t1 and t2. On that time it will be gives us the value of the four at particular 4 seconds on the time, what will be the slope of the tangent of that point. It is a difficult to show this is process graphically, but if we use the numerical, this is very difficult position. So we are discussing there, it is a difficult to show. So it is a difficult to show this process graphically, but if we use the numerical method to obtain the value of velocity, the meaning of the limiting process become clear for the graph shown in figure. See, x is equals to 0.08 into t cube. X is equals to 0.08 into t cube. See, so gives the value of delta x by delta t. Calculate the delta t equals to 2 seconds, 0.1 seconds, and 0.5 seconds, 0.1 second, 0.01 second, center at 4 seconds. The second and third column gives the value of, see here, here x is equals to 0.08 into delta t cube. So we will discussing that the value t is equals delta t is equals to 2 seconds, 1 second, 0.5 second, 1 second, and 0.0. So on that time t1 t2 and t1 t2, on that time xt1 is there, xt2 is there, and delta x it is equals to 7.84 divided by the 3 divided by the t1 minus t2. It will be 2 seconds, delta t is delta 2 seconds, so we will get that the 3.92. Then after t1 t3 minus suppose t2 minus t1 is it is a 1 second, and the delta x is the 3.86 seconds. So 3.86 divided by 1.0, so we will get that the velocity is 1. So similarly, whenever we are going to less or less or less, on that time we will get the more accurate and more accurate values. See here, it is a first of all 3.92 average velocity is there, then after we will get the 3.86 average velocity is there, then after we will get the 3.845 approximately values is there, and then after also we will get that it is a not a but also there are the 3.8402 value. But after whenever we are discussing about the 0.01 seconds, on that time we will get the 3.84000. so it is a more and more accurate result. Okay, so how much velocity are there on the p point at that particular point? See here, this time interval very less. Okay, first of all, on that time first time is 2 seconds. After that we are decreasing the time, decreasing, and decreasing of time is there 2.2 to 0.01 second. It is a small, very small quantity comparing to the 2 second. So we will get that the small and small values and accurate result of this particular point. So we will get that the 4 delta, see here, the t1 minus delta t by 2 plus t2 is equals to del t plus delta t by 2, and the fourth and the fifth column gives the corresponding values of x t1 it is equals to 0.8 t1 cube plus x2 t0. The sixth column list of the differentiation x it is equals to delta 1 2 3 4 5 6, delta x is equals to x2 delta 2 it is equals to x2 minus xt2 minus xt1. and the delta, and the last column of gives the delta x and delta t is the average velocity corresponding to the values of delta t list in the first column. So we see the from table 3.1 that we decrease the values of delta t from 2 seconds to 0.01 seconds. The value of average velocity approach the limiting value is 3.84 meter per second, which is the value of velocity at t is equals to 4 seconds. The value of dx by dt at t is equals to 4.0 seconds. In this manner, we can calculate the velocity at each instance motion of a car. So in figure 3.3, okay, for this case variation of velocity with the time is found to be shown in figure. See here, it is a velocity will be increase. After that velocity will be constant. Okay, velocity will be constant at the t is equals to 10 to 20 seconds, and 10 to 18 seconds, and after that it will be decreasing. So the graphically method of for the determination of the instantaneous velocity is always not a convenient method. For this, we must carefully plot the position of time graph and calculate the value of average velocity as delta t becomes smaller and smaller. It is easier to calculate the value of the velocity at a different instance if we have data of position at different instant or exact expression of the position as a function of time. Then we can calculate delta x by delta t from the data of decreasing the value of delta t and find the limiting value as we have done in table number 3.1. For use of differentiation calculation for the given expression, and they calculate the dx upon dt at the instant as done in the following example. Limiting value of the delta x by delta t is equals to 4 seconds. So this is our instantaneous velocity. Okay, now due to the instantaneous velocity, we will discussing about that the example. Okay, so see here, the position of an object moving along x-axis is given by x is equals to a plus bt square, where a it is equals to 8.5 meter, b it is equals to 2.5 meter per second square, and t is measured in the second. What is its velocity at t is equals to 0 second and t is equals to 2.0? What is the average velocity between the t is equals to 2 seconds and t is equals to 4 seconds? And in the notation of differential calculation, the velocity is v is equals to dx upon dt. So here x it is equals to a plus bt square, a plus bt square plus, but we are discussing about the dx upon dt square on the time. On that time, the a is the constant term, so we'll get that the constant derivation of constant term will be 0. I will explain the later explain the rules of the differentiation. First of all, so just understood here this mug up from this step, and then after I will in next lecture I will also show you integration and derivation rules. So first to see here, just a d by dt a plus bt square is equals to 2b. So here the b into t square, so we are derivating with respect to time, so 2t, so 2 will become at this side and a will be 0, so 2bt t raised to minus 2 t raised to 2 minus 1, so we'll get the 2bt, but it is equals to 5.0 meter per second inverse. We earlier b is that 0.25 meter. We will get that the value is 0.5 t into meter square. 2 into b will be give us our 2.5 into 2 will be give us that 0.5.0 meter into seconds. Suppose t is equals to 0, the velocity will be 0, and t is equals to 2 seconds. On that time the velocity will be 10 meter per second. Multiply by t 5.0 multiply 2, we will get the 10 meter per second inverse. Now average velocity of that delta x is equals to x minus x1 minus x2, xt1 minus xt2 minus xt1. So xt2 is the 4 seconds minus minus to xt2, it will be 4 minus a plus 16b minus a minus 4b. Okay, so a minus 16b, it will see here we will get that put the value x it is 2bt, so a x it is equals to a plus bt, so we will get that the a plus 16b minus a minus 4b, so a will be cancelled out, so 16 minus 4b it will be 8b divided by the 2b, so we will get that the 6 16 minus 4, so it will be 12. So you will get the 6 into 2, 6 into b, so you will get the 15 meter second inverse. So from the figures, from this we note that the during the period of 10 t is equals to 10 seconds to see. From this figure we will show that the during the 10 to 18 0 during the we note that the during the period of t is equals to 10 seconds 20 second, velocity is constant between the period 18 seconds to t is equals to 20 second. It is a uniformly decreasing during the period of t is equals to 0 to t is equals to 10 seconds. So note that the uniform motion velocity is the same as the average velocity at all instants. So instantaneous speed or speed is the magnitude of the velocity. For example, a velocity is 24 meter per second inverse and the velocity of minus 24 meter per second. Both have a associated speed of 24 meter second inverse. It should be noted that the throw average speed over a finite interval of time is greater or equals to the magnitude of average velocity. Instantaneous speed at an instance is equals to the magnitude of the instantaneous velocity at t at the instant. Okay, so now our next topic is acceleration, but we will discussing before the acceleration we will discussing first of all what is the integration formula and what is the first of all we are discussing the differentiation formula. After that we will discussing the integration formula. Okay, thank you guys. If you any kind of problem, if you any kind of comment, if you any kind of issue, if you can't understand in this topic, then comment in the comment box. I will explain in the next lecture. Okay, first of all, but please do comment, please, 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 guys. Thank you guys, thank you so much. So thank you guys, thank you so much guys, thank you.